Hello, my name is John Maddog Hall, and I am the Board Chair Emeritus of the Linux Professional Institute and the Senior Advisor for the Caninus Lucus Project. My talk today is called Freedom Means Control. In the old days, computers were physically large, logically slow, with very small memories, and very expensive. They often had no operating system at all. People would compile their programs. They would run directly on the hardware with the control device drivers, if any, actually embedded into the program instead of the operating system. These were primitive by today's standards. They used punch cards and paper tape as their storage. They had no graphics. They had no audio. They had no networking. And they basically had no security. But we loved them, and we loved IT, and we loved programming on them. Access to computers was very limited. Typically, it was government or industry or universities that had them. There were no computers in the home. There were no cellular phones or anything like that. So typically, the first time that students of 18 years of age were to touch a computer, it might be in my classroom, because I taught at Hartford State Technical College from 1977 to 1980. Things moved relatively slowly back then. And not only that, but because there was no software copyright or patents which could be applied to software, intellectual property was controlled through contract law or trade secrets. And the software was actually delivered in source code form, mostly because there was not enough of any one type of computer to be able to justify creating a binary distribution for them. And so the software provider would show up at the customer site with a tape in their hand, and they would put them on the customer system and compile them and install them and test them to make sure that what the customer had bought actually worked. And proprietary software back in those days, you might pay $100,000 for a copy of a COBOL compiler, and it was one copy that could be used by one person at a time on one machine. But you would buy it because that COBOL compiler might generate object code that would be 10% faster, 10% more efficient, and on a $2.5 million IBM mainframe, that 10% meant that it would save you $250,000. So it was worthwhile. As I said before, copyright and patents, even though they had been generated and were known in the 17th century, particularly in Italy, Florence, Italy, they were not applied to software. And so you had to protect your intellectual property, if you wished to, by keeping it secret from the customer. And then you would create a contract that would tell the customer how they could use the software, or what machines they could use the software, how many people at a time they could use the software, and so forth. Now this ended around the mid-1980s. And the thing that actually ended it was the creation of computer games, because people would generate the hardware for the game. It was typically discrete components, not even integrated circuits, but discrete transistors. So it was easy to see how the game was created physically. But there was one part on the game that was a little bit harder to detect, and that was the ROM that contained the ones and zeros for the game. And pirates would buy one copy of the game, duplicate the board, and duplicate the ROM, and then start selling it at a much lower price, because they didn't have to pay the development costs of the game. And so the game manufacturers went back to the governments and said, we need protection on the ones and zeros that are in the ROM. And we have to have a copyright on that specific set of ones and zeros. So the government granted them that, And then a little later on, they said, oh, we'll also grant a copyright on the source code that made up those ones and zeros. so that has better protection. And a little while later, they said, okay, we're going to give you patents on the general idea that you have to protect that too, for all the reasons that patents and copyrights have existed down through time. About that time, Unix was becoming into the commercial marketplace. Unix has started at Bell Laboratories in 1969. Ken Thomas and Dennis Ritchie were doing it mostly as a research program. They didn't really expect it was going to be commercially available. It was just doing research and operating system design. And so, they would distribute it to universities under a source code license that would go across the college campus. If you were not a research university, you would have to pay $160,000 per CPU, and you would have to tell Bell Labs what the serial number of your CPU was. But if you were a research university, the site-wide source code license would be $350, and there was no serial numbers needed. So a lot of universities such as Berkeley or Stanford or Carnegie Mellon or MIT would have these site-wide licenses and to be able to work on Unix and help to improve it. Now, Ken Thompson loved to go on sabbaticals, and he really loved the San Francisco area, so he would take tapes of Unix from AT&T Bell Labs to the University of California, Berkeley. And his students and professors would look at it and say, try this out, try that out, and add to that particular distribution. And so over time, this became known as the Berkeley Software Distribution, or BSD, Unix system. And AT&T continued with what they were developing at Bell Labs, which is called AT&T Unix. Now, about that time, about 1983, Unix was going to be distributed by a bunch of different vendors, like Sun Microsystems and Digital Equipment Corporation and IBM. And when they did that, most companies started to move towards a binary-only distribution because copyright would protect that at this time, and they would get a much lower royalty requirement from AT&T for doing this. So they could sell it to a lot more companies in binary-only form at a much, much lower price with much fewer restrictions by distributing it in binary-only form. If the customer really wanted the source code, they would first have to buy the source code license from AT&T, and then they would have to buy a source code license from the distributor, and that was a lot of money. So a lot of companies and a lot of universities didn't even bother to try and get that source code license anymore because it was so expensive. And this upset Richard Stallman, who was at that time a student at MIT. He wanted to see the code distributed in source code form with no restrictions on it. And so he started the GNU project for GNU is not Unix, with the goal of having a complete operating system in source code form that people could change and use in their systems and contribute back as a community-wide project. He called this the GNU project, but instead of developing the kernel as the first thing, he did a very smart thing. He decided to take some utilities and port them across different operating systems. Now, back in these days, text editors typically came from the systems vendor. You would get the systems vendor's operating system, and on top of that, they would have their text editor, which had their set of commands and so forth to be able to create a simple text file. So a developer who wanted to develop their applications across all these different systems would have to learn the text editor of that particular system in order to be able to do their work. And this was a lot of work. So the first thing that Richard Stallman did was create the Emacs text editor and port it and make it so that it could run across all the different systems. So a developer could use the same commands, the same keystrokes in order to be able to make their system work and make their editor work. And that saved them a lot of time and trouble and effort. The next thing he did was create compiler suites, going across a wide variety of different systems. And it is the same syntax and semantics for each language. So again, this made it a lot easier for developers to develop programs to go across these systems. And because these were developers who understood the problems and understood the issues, they went ahead and, like this, and they joined the GNU project in order to help out with this project of Richard Stallman's. And Richard Stallman decided to develop a license. Now, one thing that copyright did was it forced everybody who was going to distribute software to develop a license for their software. Because before copyright, you either protected your software by trade secret, which meant you didn't distribute your source code, or you had a contract. But when copyright came into being, you could say, oh, I can develop a license which will tell the user what they can do with that software and their responsibilities for that software, and I can include that with my software, and that'll be my protection. And because there came about closed source and open source, this was affected by universities like MIT and BSD, because they really wanted to distribute their source code. They really wanted people to see it. They really wanted people to use it. They were not going to charge money for it. But the other thing they wanted to do was protect themselves from suit if anybody was going to use the software and be hurt by it. So they developed their own license to go along with their source code that said basically you can do anything you want to with this, but if something goes wrong and it hurts you or your business is hurt by it, don't come back to us because you're having it as is. And these type of licenses were known as permissive licenses because they didn't put any act of being able to force the developer or the company that was distributing it to do anything else. Richard Stallman didn't like this. He wanted to have a license which forced people to say, you got this code for free. If you make changes to it and you distribute it to other people, you have to give them access to the source code just the same as you had it so that they can make changes to it, they can fix bugs, they can do that. And that is known today as a restrictive license. But in reality, I think it's actually more permissive than the permissive licenses. So the GPL in the open source land is known as a restrictive license that forces people to make the source code available to the end user. And it's also encouraged people to take their changes and move them what we call upstream, back up to the main repository of the code, so that then when people make more changes to it, it keeps building level upon level. And that's what the GPL basically does. Now, about 1991, there was a huge amount of code that was available from the GNU project, and there were other projects too, like the X Consortium project for the X Windows system. There was BSD code that had been developed for BSD, and all of these were at least open source, if not free software. But the thing that was missing from the GNU project was the kernel itself, the thing which controls all the hardware. It keeps processes separate from each other. It creates privacy and things like that. That was missing because that's a hard thing to do, number one. And number two, if you develop a kernel but you don't have anything to run on top of it, no compilers for it or anything else, then by the time you have all that done, you really have to rewrite the kernel again. But by 1991, everything was done except for the kernel. And there was this stubborn college student in Helsinki, Finland, who had gotten the internet into his home. He had a 386 computer given to him. He could use this as his hobby of creating this kernel project. And there were a lot of other programmers and developers who had accesses to 386 computers to use to develop this kernel because the 486 had already come out. And it was all the things that in the office, in the company, they were beginning to use the 486s, and the 386s were being retired to be able to be used for other things. There was also lots of documentation and white papers about how to write an operating system kernel. There were actually examples of it that you could look at. You could look at the Berkeley code. You could look at Minix, for example, and you could look at other codes. So there was a lot of information about how to create an operating system that was available in 1991 when Linus Torvalds started his project. Now, fast forward a little bit to 1994. The Digital Equipment Corporation had come out with a 64-bit reduced instruction set computer named the Alpha. It was, for 8 years, the fastest microprocessor on the face of the earth. That was in the Guinness Book of Records. But I was working for Digital Equipment Corporation in their marketing group. I wanted to see at least an open operating system so that people could do research in how to use very large address spaces, 64-bit address spaces. Now, up until that time, Intel typically had a 32-bit address space. And so people would be working with 4 billion bytes of data at one time. But 64 bits is 4 billion times 4 billion bytes of data. And that's so much data that you can store 32,000 bytes of data for every square meter on the surface of the earth, including all the oceans. That's a lot of data. So much so that very few people would ever need to have a larger address space than that. And we also wanted that to port from a complicated instruction set computer like Intel into a reduced instruction set computer like the Alpha, and various other microprocessors were available in a RISC format. But all the other operating systems that we looked at, whether it be BSD, which was still under suit from AT&T for having AT&T code in it, or whether it be SCO, which was based on System 5 and had a copyright on that, all the other operating systems were too closed to do this type of research. Because when you do this type of research, you want to be able to change the code and be able to pass around your changed code to other researchers. And none of the licenses would allow this. But Linus Torvalds had said, I want to create a kernel, I want it to be GPL, I want it to be open, and this made all the difference. So it's almost impossible to do that type of really good research with closed source operating system, because it's almost impossible to redistribute changes for review or collaboration. All you can do is write a white paper about what you did with block diagrams and hope that other researchers can implement it if they had access to source code in the first place. It's also difficult or impossible to allow changes to a broad customer base unless the company who owns the operating system code allows it. And this always requires lots and lots and lots of lawyers and non-disclosures and licensing agreements. It slows everything down. And so I advocate doing research with free software where you say, show me the code, and the person goes back and says, here is the code. It's that simple. So let's pretend that you want to teach computer science in your country, in your relatively small area of the world. People can teach from a real OS, one that's used by millions of people worldwide. They can show their students the code. They can see how it works. They can make changes to it to see how the changes affect the actual applications. The Linux kernel is the most used kernel for embedded systems. It runs on 60% of the servers worldwide. It runs on all 500 of the fastest high-performance computing systems. It is now being used in 5% of the desktop systems, 15% in India. And if you take all of the other kernels of all the other operating systems and combine them together, Linux kernels are still shipping more than all those other operating systems combined. So when you teach your students about the Linux kernel, they're going to a wide range of different jobs and capabilities for their knowledge. This is why when I tell people you use closed source software, you teach the students how to use that program to solve a problem. Fine. You teach them how to make how to use a database system. Fine. How to use an Office package. Fine. But they don't know how the program works. When you use free software, they can look at the source code for it. They can see how the program solves their problems. But in addition to that, you can teach the students how to make the program better, how to work with a group and make the code better and submit the code and test the code and so forth and so on in a real life situation. And this is not just the operating system. It's not just the Linux kernel. It's a whole variety of different pieces of software that are available to you. You can start off with data structures like linked lists, hash tables and things. These are all in the libraries of Linux. You can study how they're supposed to work. You can see code that's been optimized for making it work. Databases like Postgres, CouchDB, other databases that they can use every day to do real work, but they can also see how they do that work. Graphics, X-Windows, GDK+, all the other different things in graphics that are available, Inkscape, GIMP. You can see how they work. You can use them. Compilers, every language I've ever heard of has a free software implementation. Even Ada. The last full Ada compiler is actually a GNU project. Word processors, lots of different word processors, able to see how they work, and many, many different projects. I counted them up one time. I think there's about 400,000 different projects that exist in GitHub, GitLab, SourceForge, all of the other free software repositories. There's over 29,000 different projects and products that you can download from your Debian repository, a huge amount of software that does almost everything you'd ever want to do. And there's no embargoes on this. The source code is available all over the world. It is held all over the world. No one can stop you from using it. The fact that this is happening gives you computer sovereignty. It means that you can be working with this software no matter where you are, no matter who you are. And if somebody tries to stop you from using it, you can fork the software and use it in your own repository. So there's a hard time with business people. When you talk to them about free software, they have a very hard time of understanding free software because basically most people have a hard time of understanding the word freedom. And so I stopped talking to people about hardware and software freedom a long time ago. Instead, I talk to them about hardware and software control. Control over where you get the hardware from. Control about where you get your bug fixes from and at what time. There's no software that's completely free of bugs. However, with free software, you can reduce the mean time to fix of the problem. When the problem is known, you can get the source code patch off of the net. You can apply it to your own source code. You can compile it for every single platform that you have. It's your choice to do that. New features adding, your priority. Should you wait until free software community implements this new feature? Or can you make up your mind to hire somebody to create that feature for you? And then if you're smart, when you get that feature, you work it back upstream to allow it to come down the next time. So you never have to apply that feature patch again. You can choose the supplier of your software. You can choose who's going to make it for you. And you can decide the return on investment that you're going to make when you pay for your software. Because now you are in control. So a lot of people say, well, how can you make money with free software? How do developers make money? Well, the first thing is you have to understand a lot of these developers are making the software for themselves or for their company. They're being paid by the company to make the software work the way the company wants it to work. And so they get money that way. But they could also sell their support to other people who don't have the people working for them to do this type of work. So they are paid to fix bugs, to make extensions for other people, instead of those people having to wait for some proprietary company to put the feature in that they want. They have control. You can also bundle together hardware and software, sell it as a unit, and you make your money off the sale of the hardware or of the system. There is paid development. Like I mentioned before, somebody wants a feature or wants a bug fix. They don't want to wait for the community to do it. They pay somebody to do it. And you can have a mixture of free and closed software. So the bulk of your software is free because people don't care about that. They expect the operating system to be there. They expect it to be fast. They expect it to be secure. They expect it to be stable. And what they will pay for is a tiny little extension to that, which allows them to do the thing that they want to do. But this makes the bulk of the solution a lot less expensive because you're not paying for the operating system or anything else. You're only paying for that little bit, which is what the customer really wants. And there are many, many more models to think of in the free software model place. There's many books written on it, articles written online. So if you're interested in making money with free software, the answer is there. With that, I thank you very much for listening. My name is John Maddog Hall. I'm the board chair of the Linux, board chair emeritus of the Linux Professional Institute, and the co-founder of Project Kawan and of Caninos Lucas. Again, thank you very much, and good night.